Hello everyone, welcome back to my channel. Today we are going to start one of the most important and interesting chapter of inorganic chemistry, the S-block elements. Before we open the periodic table, just think about a very common substance around us, such as salt, baking soda, washing soda, plaster of Paris, cement, etc. Have you wondered what chemistry involved behind this everyday material? Yes, a major part of the story comes from S-block element. And although the chapter may look simple, it has lot of important chemistry hidden inside it. So in this class, we'll discuss introduction, occurrence, its periodic trends, and also few physical properties of S-block elements. Let's start our journey into the inorganic chemistry of the S-block elements. Are you ready? Yes. So S-block elements, introduction. First, before understanding about S-block elements, first we have to understand what is S-block element, what is its definition. The outermost electron or the differentiating electron enters the outermost S subshell or S orbital. We will call it as a S-block element. The S-block element is divided into two groups, group 1 and group 2. Under group 1, we have lithium, sodium, potassium, rubidium, cesium, francium. Then under group 2 elements, we have beryllium, magnesium, calcium, strontium, barium, radium. Do you know its atomic number? We will revise that one. Lithium atomic number is 3, sodium 11, potassium 19, rubidium is 37, cesium is 55 and francium is 87. Beryllium atomic number is 4, magnesium 12, calcium 20, strontium 38, barium is 56 and radium is 88. Next, if you see the general introduction of S-block element, they are saying that it is very highly electropositive in nature. They are very highly electropositive in nature. What is the reason? Because in the outermost shell of the group 1 is having only single electron. For group 2, it is having 2 electrons. To become stable, okay, to become stable, what they will do, they will simply lose one of its outermost electron and they become stable in nature. Okay, always they doesn't exist in a free state. Always they want to combine with other elements to form a mineral or ionic compounds. Every time the S-block elements try to combine with P-block elements and they form a ionic or minerals. Here, because of that reason, they are very highly electropositive in nature, and these elements are very soft and they are having low ionization energy, and they are located at left side of the periodic table. Then what is the general electronic configuration for group 1 element, which are alkyl metals? Why we are calling it as alkyl metals? Because they react with the water to form hydroxides. They are very strong alkaline in nature. So it is having a general electronic configuration of group 1 element is NS1, and for group 2 element it is NS2. Then if we see the key characteristics, it says that the group 1 element are monovalent in nature. The group 2 elements are divalent in nature. Ma'am, what is monovalent? What is divalent? Monovalent means the electron, already we discussed here, the group 1 element having only one electron in its outermost shell. Because of that reason, they are having tendency to lose easily only one electron. So it shows a monovalent ion. The group 2 element loses 2 electrons which is present in its outermost shell. Then it forms a divalent ions. Here you can see the metal is losing electron. Metal plus we are having removing of one of the electron from the neutral atom. Then they are having low ionization enthalpy. They are very low electronegativity because they are very highly electropositive in nature, and mostly they form ionic compounds. They are good conductor of electricity. Ma'am, what is the reason of good conductor of electricity? Because they lose electrons as easy as possible. Because of that reason, free electrons conducts electricity. So S-block elements are very good conductor of electricity. And they are metals. They are very soft in nature. If you take sodium, what happens, Nana? If you cut with a knife, it will cut into 2 pieces as easy as possible. They are very soft and they are present in silvery white. Okay, they are having very low density and low boiling point. As you compare the group 1 with group 2, group 1 elements are highly reactive metals. As you go down the group, the reactivity increases. But when you see for group 2 elements, they are less reactive compared to the group 1 elements. But they are very reactive compared to the other group elements. Okay, at last we understood the group 1 elements are very highly reactive. They are having a low ionization enthalpy and they are soft metals. They are having What, Nana? They are silvery white and they have low density, low melting point, low boiling point. Its general electronic configuration is ns1, and for group 2 it is ns2. You have to remember the elements: lithium, sodium, potassium, rubidium, cesium, francium, and group 2 elements: beryllium, magnesium, calcium, strontium, barium, radium. Is it clear, Nana? We will go for next slide. Here, if you see, here occurrence is there. Yes, definitely we have to understand where the alkyl metals are present. Alkyl metals generally present in the form of minerals. They are not liking to exist in a free state. I will say one simple example. One student was present, and he is very close with his best friend. Without him, he can't exist in the class. He can't stay. Okay, definitely he has to sit beside him. He has to learn. He want to enjoy with him, and everything he want to do. In the same way, the sodium is having, or the S block elements are having a friendship with P block elements. Always they want, or D block elements also, always they want to combine with other elements and form a common minerals. What are the common minerals? We will see. A lithium is present as a spodumene, lipidolite, then sodium present in rock salt, potassium present in sylvite, carnallite, then rubidium present as a polysite, then cesium present as a polysite and lipidolite, then francium is very rare, minute quantity in a radioactive minerals. Why it is very rare? Because the francium is a radioactive element. It's having an isotope 223, where its lifespan is only 21 minutes. This is a reason. Because of because of its highly reactive nature, always they want to exist in a mineral form instead of free state. So what are its physical property? In the before slide only we understood these metals are soft, silvery white, and they have very low density. And they are having a high malleable. Malleable means making into shape. We can change the shape of that metal. And ductile, it can be stretchable. The metals can be stretchable. Then they are good conductor of heat and electricity. And tarnish quickly. What is tarnish? Tarnish means changing of color or shine. Because I already said that the alkyl metals are very highly reactive. Whenever they get any elements like oxygen, water, and carbon dioxide, molecules, what they will do, definitely immediately they want to react with them, and they form a different compounds or ionic compounds. Because of that reason, what they are doing, they are storing in a kerosene oil. What they are storing, Nana? They are storing alkyl metals. So in this picture you can see the sodium stored under kerosene. Okay, definitely we have to store it. If you are keeping it open, what happened? They immediately react with oxygen, water molecule, and carbon dioxide. As you see the reactivity order of the alkyl metal, lithium is having less reactivity compared to sodium, potassium, rubidium, cesium, and francium. As you go down the group, what happening? The reactivity is increasing. Okay, try to remember the sequence, Nana. Don't get confused. It's everything is simple, but you have to revise the concepts as many times as possible. Then if you see atomic and ionic radii, it is very simple. By seeing the image only, we can able to understand that lithium is very small compared to sodium. Sodium is very small compared to potassium, then rubidium, then cesium. The size of the elements are increasing as you are going down the group, because what it is explaining to us, actually they are explaining the periodic trends. Okay, in this particular third atomic and ionic radii, they are explaining us a periodic trend. As you go down, the atomic radius and ionic radius is increasing, because the number of shells are added. For suppose if you take lithium, it is having only 2 shells. For sodium, it is 3 shells. For potassium, it is 4 shells. As you go down the group, the number of shells are increasing. But when you compare the atomic radii and ionic radii, the size of the ionic radii is somewhat very smaller compared to the parent atom. This thing you have to identify. Here see, ionic radii is very small compared to the parent atom. Parent atom means the atom, the element which is present in its we can say normal state or neutral state. Okay, then if we go for ionization enthalpy, what first thing you have to understand, what is ionization enthalpy? Ionization enthalpy means the amount of energy required to remove an electron from its outermost shell. That is ionization enthalpy. Then metal, when it is supplied some amount of energy, what happening, Nana? The electron was removed from the element which is from outermost orbit or outermost shell. Low for all alkyl metals, and decreases down the group. What is the reason? What is the reason for decreasing down the group? What it is? Ionization enthalpy is decreasing down the group. What is the reason? Because atomic size is increasing down the group. Number of shells are increasing. Because of that reason, the attraction between the nucleus and outermost shell is very active here, very strong here. But as you move down the group, the attraction between the nucleus and outermost shell is decreasing. Are you able to understand? It is decreasing. Because of that reason, the last electron is not having that much attraction between the nucleus and also electron. So it is having very low ionization energy. Very less energy is required to remove that electron. Uh, are you able to understand now? Okay, we will see the trend now. Lithium is having more ionization energy compared to sodium, then potassium, rubidium, cesium, and francium. From down the group, the ionization energy is decreasing. You can see the graph also here. As you go down the group, the ionization enthalpy values are also decreasing. Then hydration enthalpy. What is hydration enthalpy? Enthalpy change. Okay, when 1 mole of gaseous ion is surrounded by a water molecule to form a aqueous ion. What is aqueous ion? When the metal which is in a ionic form is reacted with water molecule and they form a aqueous ion. Okay, are you able to understand now the sequence? Metal is reacted with the water molecule, n number of water molecules, and they forming a ion, aqueous ion. Here in this picture you can observe that metal was present in the middle, then around that a small water molecules are they are forming a cloud like thing around the metal. So as you see the trend, the lithium is having more hydration energy compared to sodium, potassium, rubidium, and cesium. And why the lithium is very small, okay, and the cesium is very big? Then the lithium is not having it should not have hydration enthalpy much, no. The cesium is having larger size, so many water molecules can join with them, right, attract with them, right? No, it is not happening, because here the lithium is having a more high density charge. It is having more high density charge. What is the high density? The positive and negative, of the atom concentrated at very small portion or small volume or space. Because of that density, the more number of water molecules are surrounded by the lithium atom. It become a bulky aqueous ion. It become a bulky aqueous ion. When to understand easily, I will explain with one of the easy example. See, we are at home and a very small child, your relative, came, and he is very active and he is completely changing the places of the objects for some time. Then you are not having that much patience, and you started to asking their parents to make him to sit at one place. Then what they will do, they will make their child to sit beside him, one side with mother, one side with father. Yes, now what happened at that time? The child will stop moving and he will be staying at one place because of the under control of the parents. In the same way, the lithium is small. The lithium is small, but because of its high density, what happening, Nana? It is forming a bulky aqueous ion and it is having a low mobility. It is having a low mobility as compared to the cesium. In this picture, if you see, you assume it has a cesium. Cesium is surrounded with 5 water molecules. But if you assume lithium, it is surrounded by 20 water molecules. Now you got a clarity? Yes. Next we will go for the a small revision we will do here, summary table. Before that, we have to understand the hydration enthalpy is a exothermic and it is a negative value, because almost all alkyl metals are highly reactive and they show exothermic reactions. Exothermic means releasing of heat, okay, releasing of heat. So the properties are atomic radii. Lithium is very small, and the sodium increases down the group. For ionic radius also increases down the group. Ionization enthalpy decreases down the group. And the hydration enthalpy for lithium, it is more negative. As you go down the group, the negativity was decreases. As I said, you assume it has a cesium and it is surrounded with only less, okay, less water molecules, and the cesium is having good mobility, but as compared to lithium, okay, lithium is having very poor mobility and it is bulky aqueous atom, and the cesium is somewhat less aqueous and it is not having a hydration, much hydration enthalpy compared to the lithium atom. Okay, ma, I thought you are able to understand what I'm teaching. If you are not getting, please comment below. Then we will see the density. You can see the table also here, the element of lithium, sodium, potassium, rubidium, cesium, and francium. Francium is radioactive, we already know. Because of that reason, they are not able to calculate accurately the density. As you go down the group, what happening, Nana? The density is increasing. The density is increasing as you go down the group. But one thing you have to understand, the lithium is less dense than water, so it floats. Okay, so what they will do, they will store, definitely they have to store alkyl metals in either in kerosene, but what happening here, less denser, and also in kerosene also, if you keep this lithium, it will float. So what they will do, they will cover this lithium element with wax. Okay, they will cover this lithium with wax. Then they are having a very low density compared to the other elements. Then if you see here melting and boiling point, both melting and boiling point are low, the decreases down the group. You can see the values also here. As you go down the group, the melting point decreases. As you go down the group, the boiling point is also decreasing. Then flame color test. The alkyl metals show different colors because the outermost electron, the electron is making this color to impart, or this color to shown by the that single electron. Okay, because when the energy was absorbed, the Bohr's model explains us that hydrogen spectra, where we have understood that outermost electron absorbs the energy, and it will go to higher energy state. At higher energy state, the stability is less but energy is more. At that time again it will come back to its original position. When it is compacting, it will radiate some energy. That energy can be visible in a visible region. Because of that reason, the lithium, when the lithium element was exposed to the flame, it will show crimson red. Sodium will show golden yellow. Potassium will show pale violet. The rubidium will show red violet. The cesium will show blue violet. Okay, these colors you have to remember. By actually where these colors are useful means while you are doing salt analysis experiment. Okay, at the time if you observe crimson red, then you can able to understand it is having a lithium cation. Next, if we see for photoelectric effect, the photoelectric effect is nothing but we will be radiating some light. At that time the elements will absorb that energy and it will start losing its electrons. They easily emit electron when light of sufficient frequency falls on their surface. Has the larger atomic size down the group. Yes, as you go down the group, what happening, the size is increasing because number of shells are increasing. Outer electron is held loosely, because of that reason it is easily loses its electron. So the cesium, the potassium, cesium are used in a photoelectric effect, and least used is lithium. Lithium is used in electrochemical cell. Then if we see the that order of reactivity, cesium is very less compared to rubidium, potassium, sodium and lithium. Okay ma, that means as you go from top to bottom, what happening, the photoelectric effect is decreasing. Then if you see for reducing nature, alkyl metals are very good reducing agents. Do you know what is good reducing agents? Yes, if don't get confused between reduction, reducing, oxidation and oxidizing agent. Nothing but the reducing agent means these elements will lose electrons easily and they will reduce other elements. That means they donates the electron to another element. That type of functioning is known as reducing agent. Alkyl metals are very highly good reducing agent because they lose electron very easily and get oxidized. Here if you see the reaction that in the table, the metal is reacted with water and they are forming a metal hydroxide by releasing hydrogen gas. Here the metal is reacted with water molecule and the small bubbles are formed, which you can see the hydrogen gas is collected here. This is how the reacting and reducing nature was shown. And here you can see the metal and observation with cold water. Lithium will show slow reactivity. Sodium reacts moderately. Potassium react vigorously. Rubidium very vigorously. Cesium will explode. You understood? As you go down the group, the reactivity order is increasing. Here you can see the key idea. Down the group, atomic size increases. Attraction for outermost electron decreases. Yes, the properties like melting point, boiling point and photoelectric effect is also decreasing down the group. Reactivity and reducing nature increases down the group. This is what we have studied today. If you have any doubts, any questions you want to discuss, please you can question in a comment box. I will